Hi everyone, so welcome back to Mrs. Riley's math videos. I wanted to run through a quick talk through on exercise 18.6 in active maths because that's what Form 5 are working on tomorrow, and I just want to talk you through some of it because I know it's a bit more confusing. Okay, so I'm just getting my pencil here. So I've asked you to do question 5 and question 6. What we're being asked to do, is to find the equation of each line. So remember, to find the equation of the line is y minus y1 is equal to m by x minus x1. To find the equation, we need a slope and we need a point, x1, y1. So slope m and a point x1, y1. So what we've got to assume is that they must be giving us enough information in this to get a slope and to get a point x1, y1. Now remember, if we have 2 points, x1, y1 and x2, y2, then we can find the slope, and there's a video on how to do that, and then we can use that slope plus the point to find the equation. Okay, so there's different options of finding the equation of a line, but basically we need a point and a slope. Now, so let's look here. I'm going to just put some paper over here so that I can write in it. So let's look here at this set of lines. Here we've got line L, line K, and line J. Now, we can either just say line L, it has the points 1, 2, and the point 0, minus 2. We could find the slope using that, x1, y2, so y2 minus y1 over x2 minus x1, which is minus 2 over 0 minus 1, so minus 4 over minus 1, which is 4. That gives us the slope, which is m, and now we can do y minus y1 is equal to m by x minus x1, and so on. Or, if you wanted to, what you could do is you could do rise over run, and we could look and see, because we've got a diagram, what's the rise, what's the change in the y compared to the change in the x. So the change in the y going from here to here, change in the y is down 1, 2, 3, 4. The change in the going from left to right, of course, is what we should be doing. Sorry. So the change in the y going from here to here is up 1, 2, 3, 4, and across 1, so it's 4 over 1, which is 4. So the diagram can help us to find the slope more quickly if we want to do it visually. Otherwise, we just use our y2 minus y1. So if you look at J, what are some points on J? We've got minus 2, 1. We've got 3, 1. And hopefully looking at J, you'll say, oh, well, it's not going up or down. And it's not going up or down. It's got a slope of 0. Okay, so that'll make a difference. And then this line K has got points. Well, it's got minus 2, 1. And it's also got, for instance, 2 minus 3 or 1 minus 2. So that's some other points there. It's similar when we go on to question 6. Again, we have, what do we have? We have this line here, L, which contains the point 0, 12 and 6, 0. Again, we can use those points. The line J is an unusual again because it looks weird, doesn't it? It's just going straight up and down, and it's got a slope which we say it's undefined slope. So actually I'm going to help you out here and say that any line that goes parallel to the y-axis, its name is x equals something. So this line here, if I was to draw this line here, this would be the line x equals 4, because every point on that line has an x value of 4, so that becomes its name. I'm not going to do J for you because you can do it now yourself. And then line K contains the point 0, minus 6, the point 2, 0, and if we needed another one, which we don't, the point 5, 9. Okay, so hopefully that helps you with questions 5 and 6.